Hello everyone, it's good to have you here. It's been about a year since my last video, and this is another video, explanation video, to complete my inorganic chemistry assignment about acids and bases, specifically the hard acid and base theory. However, this video is going to be a little bit different, as you may already notice. This video is going to be in English, so I hope my Indonesian viewer can still follow, and also any international viewers that may catch up to this video. Also, sorry if there are any distracting sounds. I'm currently recording in the morning, and I don't have a soundproof room, so yeah. Anyway, let's get into it, shall we? In the early year of 1960, Ralph Gottfrid Pearson, a US physical inorganic chemist, introduced the HSAB theory, or hard-soft acid-base theory, as an effort to connect the branch of inorganic and organic chemistry. Pearson said that Lewis acids and bases can be classified as hard or soft acids and bases. Soft acids and bases can be easily polarized, meanwhile the hard acids and bases cannot be polarized or difficult to be polarized. This hard-soft acid-base theory is also known as Pearson's acids and bases. In 1963, Pearson introduced an HSAB principle where ligands with high electronegativity and small radii are hard bases, and ligands with low electronegativity and large radii are soft bases. Meanwhile, metal ions that are small but have a high positive charge and a low electronegativity are classified as hard acids, and metal ions that are large with low positive charge and high electronegativity are soft acids. According to hard-soft acid-base theory, hard acids will interact with hard bases forming complexes. This also happens with the soft acids and soft bases. The interaction of hard acid-base is ionic and the interaction of soft acid-base is covalent. The hard-soft acid-base theory also explains the stability of compounds and used in qualitative context to understand the factor of a chemical reaction, especially in transitional metals. Soft acid and base will react faster with each other and form a strong bond, and hard acid and base will react faster with each other, also forming a strong bond. Certain metal ions form stronger interaction with certain ligands. This observation led to a classification system called hard and soft acids and bases, developed by Pearson. It is a theory that we can use to predict which metal ions and ligands will interact most favorably. Lewis acids and bases can be classified by designating them as hard or soft. The classification are based on three factors. First is the charge density or charge to size ratio. Second is the polarizability. And then third is the covalent versus ionic nature of interactions. In general, hard acids and bases have a high charge density, not very polarizable, and form bonding interactions that are more ionic in nature. These atoms and ions tend to have high charge and/or small radius. In the other hand, soft acids and bases have a low charge density, more polarizable, and form bonds that are more covalent in nature. These atoms and ions tend to have low charge and/or large radius. And then there are intermediate acids and bases. These are acids and bases with intermediate character, between hard and soft. An element can have a different hard-soft character depending on its oxidation state, and whether or not its polarizability is affected by surrounding atoms and bonds. The most extreme example is hydrogen. where H plus is a hard acid and H minus is a soft base. Nickel 3 plus, as in the layered compound nickel oxide hydroxide, is a hard acid, but nickel 0, as in nickel tetracarbonyl, is a soft acid. Nitrogen is hard when it's an amine or minus NH2, but the nitrogen is a pyridine is borderline due to increased polarizability imparted by aromatic ring. Hard soft acid base have like binds with like principle. Hard acids interact more strongly with hard bases than they do with soft bases, and soft acids interact more strongly with soft bases than hard bases. Thus, the most stable complexes are those with hard and soft interaction. And then, as you can see, this is the table of hard soft acids. The hard acids are colored in orange, the intermediate acids are yellow, and then the soft acids are blue. The characteristic of hard and soft Lewis acids also can be seen right here. The hard Lewis acids have low electronegativity with high charge above 2+ and a small radii. The soft Lewis acids have high electronegativity, low charge +1 or 2, and a large radii. However, the hardness can be affected by the oxidation state of the metal. Hard acids are typically metal ions with high positive charges and smaller ionic sizes. Early transition metal ions in the 3D series tend to be hard Lewis acids. Soft acids are typically transition metals with +1 charge, like copper, or that are in the late 4D and 5D series like cadmium 2+ and mercury 2+. Next is the table of hard-soft bases. Hard Lewis bases have high electronegativity and small radii. Soft Lewis bases have low electronegativity and large radii. Hard bases are typically small anions and neutral molecules. Some examples of hard bases include hydroxide, fluoride, chloride, and ammonia. Soft bases are typically larger anions and neutral molecules. For example, are iodide and sulfide. These are the classification of hard-soft acid base. For example, hydrogen, lithium, sodium, potassium, rubidium, cesium for the hard acids, and then gold, silver, copper, and mercury 2+, and also cadmium 2+ for the soft acid. And for the bases, fluoride, water, hydroxide, oxygen, and so on. And for the soft bases, there are iodide, bromide, cyanide, and carbon dioxide. You can pause this video to take a closer look if you want. And you might be wondering, how does this theory work with a reaction? So hard-soft acid-base theory predicts whether a reaction will occur or not. A strong acid will react with a strong base and vice versa. These are some of the examples. Mercury to fluoride plus beryllium diiodide resulting into mercury iodide plus beryllium fluoride. As we can see over here, the mercury is a soft acid and the fluoride is a hard base. The beryllium is a hard acid and the iodide is a soft base. The result follows the principle of hard-soft acid base. The mercury pairs with the iodide and the beryllium pairs with the fluoride. Next one is the hydroxymethyl mercury plus hydrogen sulfide. The result is monomethyl mercury sulfide plus water. This also follows the principle, as we know. The monomethyl mercury is a soft acid and the hydroxide is a hard base. the hydrogen is a hard acid and the sulfide is a soft base. The result follows the principle because the monomethyl mercury pairs with the sulfide and then the hydrogen pairs with the hydroxide. From the example above, we can infer that the hard acid-base pair, beryllium fluoride and water, are formed from covalent bond. On the other hand, the soft acid-base pair, mercury iodide and monomethyl mercury sulfide, form a covalent bond. Okay, that was all that I can tell you about the hard-soft acid-base theory. I hope this helps you in some ways, and please leave a like if it does. Thank you very much for watching, and I will see you in the next video.